I am so done with science videos, okay? They make me do 4 whole videos that take 10,000 hours to edit. I'm just so done. I'm so angry. I just need to take my anger out on something. Ah! Ah! Ah!
Hadouken! Perfect.
Boy, do I feel better, but I still need a topic to talk about that's completely unrelated to science. How about math? And you know what my favorite kind of math is? That's right, as you guessed it, AP Calculus BC FRQs. Let's go. To start off this FRQ, we want to make sure we have all the information that we know from the beginning of the problem. The problem gives us the Maclaurin series for a function of f is given by the summation of x equals 1 to infinity, which is x minus 3 over x cubed minus 27, which will, the next few terms will be 1 over 9 minus 1 over 27x plus 1 over 243x cubed till the eventual heat death of the universe, which will lead us to a function of negative 1 to the x times the function 0 over x factorial. And that is our entire written out information. So for part A, we're going to focus namely on this part of the equation. So let's rewrite that right over here. X minus 3 over x cubed minus 27. Now, this actually looks like another equation. So we must use direct comparison. You see, direct comparison tells us two things. It tells us, one, if the summation of a function similar to the first function is convergent, then so is the summation of the first function. These two are labeled b of n and a of n respectively. It also tells us something similar, that if the summation of the first function is divergent, then so is the summation of the second function. So, if a of n equals our original function, which is x minus 3 over x cubed minus 27, we must find something similar to that. So, b of n must be similar. And so what is something we can take away from this first function that won't affect the equation very much at all? These two constants. So we take away these two constants, the equation becomes x over x cubed, which then goes to 1 over x squared. And this is our b of n. So we see here that the summation of b of n is also equal to the summation of 1 over x squared, which is b of n. And so if we see that as this function approaches infinity, we see that it gets closer and closer to 0. And so since this gets closer and closer to 0, this series is convergent. And so going back to what direct comparison says, we now see that if the sum of b of n is convergent, like we just proved, then so is the sum of a of n, which then says that our original function is convergent. Well, good job, you guys. We finally finished the first part of the FRQ. We did so well that I am now going to change my name to Mr. Math. But wait, we're going to need some help if we're going to finish this FRQ. I have just the person. Hello, Mr. Ematics. We need your help.
Namaste everybody. Today we will be learning about how to do this problem. Very nice problem, you see, very complex problem, very interesting problem. But we have to break it down if we want to complete it, because it is no easy feat, I will tell you. So, my name is actually Dr. Rajeshwari Ematics. Very profound professor at my college. I am actually at the Chennai Institute of Technology and Mathematics for NASA development. No, very simple though. Hard work will get you anywhere. Carrying on. So for our problem, we have n minus 3 is over n cubed minus 27. Now, very simple simple equation, let me tell you. But expression actually, expression. But how do we simplify it? I do not know yet, but we will figure it out. So let's see. So if we factor at the bottom, we get n minus 3 multiplied by n squared plus 3n plus 9. So we have this one, but how do we simplify it? How do we get that into a proper form where we can use and evaluate the expression so that we can simplify this fully? We should just do this. We should take this expression as I have a over n minus 3 plus bx plus c over n squared plus 3n plus 9, and we should then multiply this by the expression as needed. The expression we need is n cubed minus 27. After a complex set of computations, continuing on with the problem, n minus 3 is equal to a times n squared plus 3n plus 9 plus bx plus c times n minus 3. Now what we have to do then is we have to separate this into component parts, no? So let us have n is equal to 3. When we plug n is equal to 3 into this top expression, equation, whatever you want to call it, does not really matter at this point, because 0 equals 27a plus 0. Okay, so then we arrive at a is equal to 0. Oh, Baya, that is very funny, no? Very funny. So we take the n a equals 0 equal to 0 expression. We input back into the original expression that we derived. N minus 3 is equal to 0 plus bx plus c times n minus 3. Now listen, Baya, what is this stupidity you see? 1 is equal to bx plus c. Bx plus c is the original thing we had. Correct? Correct. So then we arrive at the original is equal to 1 over n squared plus 3n plus 9. Add a partner. So, namaste everybody. Very good job with the completion of the problem. Very happy that you completed the problem. This is our final answer as the fraction is simplified. As you can see that this expression carries no value, so we can eliminate that completely. Very good job. Back to you, Dr. Math. Back to you.
And for the last section of this FRQ, we have the summation of x equals 1 to infinity of x factorial over x squared. So we want to do, to find the radius of convergence, we need to use the ratio test. So first we're going to take the limit of a sub n plus 1. So we make sure every x plus 1. So x plus 1 factorial over x plus 1 squared times the reciprocal of the original function, which is x squared over x factorial. After some multiplying out, we simplify it down to x squared over x plus 1, since the factorials cancel out. So this then, once you divide every single term by x, the highest term in the denominator, we get 1 over 1 plus 1 over x, which once you plug in the infinity, gives you 1. When you have 1, the test cannot be determined and convergence is inconclusive. And that is the answer.